Hello, everyone. Thank you so much for joining us today. My name is Corey Ruth. I'm with IEEE SA Marketing and Communications Marketing and Communications Manager. We have uh, an outstanding presentation for you here today on this live stream with three brilliant experts in the field of Wi-Fi HaLow. Over the next hour or so, we're going to be speaking with Zach Freeman, Dr. Yasushi Takatori, and David Halaj about Wi-Fi HaLow 802 IEEE 802.11 and why it's the future, or one strong component of the future of long-range wireless. We're going to be having perhaps some difficulties with David's connection. Unfortunately, he's having some technical difficulties. We are coming to you live from all over the world, quite literally. This is 100% live. No portion of this has been pre-recorded, and unfortunately, David is dealing with some internet connection issues where he is. So we're going to be able to hear him, but may not be able to see him, and so we'll just go with it as best as we can. All right, so a couple of housekeeping items just before we begin. As I mentioned, this is a 100% live presentation, and one of the great things of that is we're going to be able to answer your questions live as well. If you do have questions for our speakers as we go along, just put those in the comments section. Whether you're joining us from YouTube, Facebook, or LinkedIn, and we'll be able to pull those onto the screen just like this and have our speakers be able to answer those. We likely will have quite a few questions, but we'll get to as many of them as possible, and we always appreciate the great questions that come from our audience. All right. So moving on in here, we will introduce our speakers. First up, we've got Zach Freeman, who's the Vice President of Marketing and Sales at Neuracom. Zach has 20 years of experience, or more than 20 years of experience in embedded technology and wireless connectivity. got his Bachelor of Science degree from the U.S. Military Academy at West Point. He was previously Vice President of Silex Technology, leading the sales, marketing, and engineering organizations. He's based in California, and Newercom is a leading developer of wireless connectivity technology and the first to market with Wi-Fi HaLow SoCs.
Yeah, thank you, Corey. It's great to be here.
Yeah, thanks so much for joining us, Zach. We also have joining us from Japan, Dr. Yasushi Takatori. He's a Senior Distinguished Researcher of NTT Access Network Service Systems Laboratories. He previously served as Vice Chairman of the IEEE 802.11ah Promotion Council in Japan. He's the former Vice Chairman of the Wireless LAN System Development Project in the Association of Radio Industries and Businesses, and has a PhD in Wireless Communication Engineering from Aalborg University in Denmark, a BE and an ME degree as well from Tohoku University in Japan. So welcome to Dr. Takatori as well.
Thank you. I'm glad to be here today and expect a fruitful discussion. Thank you.
Excellent. All right, thank you so much. And as mentioned, with a little bit of technical difficulties, we have also joining us through a phone connection, David Halage. He's the Director of Standards for Morse Micro and the first Vice Chair of IEEE 802 LMSC. He's currently engaged in leadership of the Wi-Fi HaLow Task Group, has served as Task Group Chair of IEEE 802.11ah and IEEE 802.11i. He's involved in the formation of the Wireless Ethernet Compatibility Alliance, WECA, which is now known as the Wi-Fi Alliance. While working at Cisco Systems, David was recognized as a Cisco innovator, and he also holds 12 patents with 30 plus years of experience in the wireless industry. So welcome, David.
Well, thank you very much.
All right. So a couple of just quick notes about IEEE SA, or IEEE Standards Association. We are the leading consensus building organization that nurtures, develops, and advances global technologies through IEEE. We facilitate standards development and collaboration with thought leaders in more than 160 countries, and we promote innovation, enable the creation and expansion of international markets, and help protect health and public safety. Collectively, our work drives the functionality, capabilities, and interoperability of a wide range of products and services that transform the way people live, work, and communicate. All right, so with that, we're going to kind of give a little quick intro of what is Wi-Fi HaLow, what is IEEE 802.11ah. We'll maybe start with Zach and then go to Yasushi and then to David. So Zach, in a minute or so, what is Wi-Fi HaLow to you?
Yeah, so to me, if you were to really distill it down, it's the Wi-Fi that we know and love and are likely using right now around the world, with the characteristics of a low power wide area network. So we move traditional Wi-Fi to sub-gig, and we add some optimizations, and then it becomes Wi-Fi really designed for IoT.
Awesome. So it's got all of the things that we know and love, but just some little tweaks to make it more ideal for IoT, basically, right?
Absolutely.
Yeah. Excellent. All right. Thank you so much. And Yasushi?
Yeah. I think Wi-Fi HaLow 11H is a very powerful IoT tool. And in Japan, we are tackling to aging society. So digital transformation is really important. And we are expecting powerful IoT solutions. But the current IoT solution is not sufficient for various solutions. For example, so there are many LPWAs, but the data rate is not so high. So we cannot use it for video transmission and so on. But now 11AH Wi-Fi Halo can do that. That's a very, very powerful tool. And I think that is the key technology to success the digital transformation in Japan. Yeah. Okay.
All right, excellent. Yeah, thank you. And for David, what is Wi-Fi Halo? What is 802.11AH for you?
Yeah, it's basically Wi-Fi's approach, specifically targeted IoT, bringing long range and low power consumption. So this is basically where if the other forms of Wi-Fi are very broad based and that where they go faster, and sometimes at the expense of other feature functionality that you'd want for IoT. And then here we kind of looked and said, well, you know what? We want to specifically take Wi-Fi and target it at IoT.
All right, excellent. Thank you so much for that description as well. Moving on in from here, I think it makes sense given we're looking at how it's got a lot of similarities with traditional Wi-Fi. Let's look at how does Wi-Fi Halo differ from traditional Wi-Fi? Maybe a couple of the top points here. Again, let's maybe start with Zach.
Yeah. Yeah. So I mean, the most visible and the one that finds the most drivers for implementation is around the range and the material penetration. So right there, by moving from 2.4 or 5 or even 6 gigahertz into sub-gigahertz space, that longer wavelength will reach a lot further and it will penetrate material a lot better. And so this kind of manifests in two ways. One is a much lower cost to deploy. So where before you may have had 10 regular Wi-Fi APs on one floor of one building, you may be able to cover multiple floors with a single Halo AP. So it's a lot like Wi-Fi, but at a much larger scale. And then on the flip side, what's really interesting and exciting for us is because, again, of that low frequency propagation, we don't need as much power to transmit the same distance. So we can also see the benefits from the low power consumption side of it. So what does that do? It really opens up, a lot of the fundamentals are the same of Wi-Fi, but the applications really tailor itself to IoT type of devices, right? Devices that need to maximize battery, devices that could be placed in inconvenient locations.
Awesome. So we got the long range, low power consumption, great material penetration through walls, through floors, that type of thing, and a low cost of deployment as well. Like that I mean, it's more than a trifecta, of very nice things for IoT. So we're talking like sensors, cameras, all that kind of stuff that this would be perfect for.
Yeah, exactly. And that's what we're seeing today. Both indoors, imagine a building monitoring system, or outdoors, agricultural or construction. So, you can use those tools and shift the technology in a number of different ways.
Okay, excellent. So maybe we'll go next to Yasushi. In some other differences, can you talk to the throughput differences maybe of Wi-Fi Halo versus traditional Wi-Fi?
Yeah. So can I use my slide? So is it okay to show my slide?
Oh, of course.
And we go to slide 3.
Sure. Let's just pull it here. So I think we've got, let's see here.
Will you change this slide and will you go to the slide 3? So,
Okay, we got data study cycle.
No,
basic
no. Go
registration.
to the. Will you go to the first page or? Ah, okay. Then I just want to explain the difference from Wi-Fi or other wireless technologies 11H. So I think there are many requirements for IoT wireless access. So of course, the throughput is important, and also as Zach mentioned, the coverage, uh, range extension, and also low cost and the lower power consumption. And the other than that, we are thinking that the easy installation is very important. So it's it's not like different, but it's very similar to Wi-Fi. So it's very easy to deploy to various solutions. And the also 11AH can we can expect massive connectivity because this 11AH is designed for IoT Wi-Fi, so it can support a large number of wireless devices. That is also important, I think. So of course, compared to Wi-Fi, this range extension and so on, that's very important. But if we compare performance with LPWA or NB-IoT or that kind of IoT wireless access, then we can expect a higher throughput and so on. So I'm really thinking that the 11H is very powerful for various IoT solutions.
Mhm. Yeah, agreed.
Okay,
Maybe
great.
I'll add a little bit to that. So I was
Sure.
very excited when I think about what we're 2014, almost 4 years. 4 years ago, I had the first opportunity to use a HaLow device. So when I
Mm,
had that opportunity, I jumped on it right away, and it felt like having a little cell tower in my hand. I
nice.
placed it on the second floor of my house, and I was able to get a connection at my son's school, which is about 800 meters away. And
Wow.
having been, in Wi-Fi, traditional Wi-Fi, for a very long time, I've done a lot of 2.4, 5 gigahertz, 6 gigahertz now, and even 60 gigahertz for a little while. It occurred to me, this is what a lot of the applications that I engage with, machine to machine or IoT, were looking for a solution, and they were looking at other options because HaLow was not there. So either in the LP WAN side, so think like Sigfox or LoRaWAN or NB-IoT, and they weren't quite the right fit for many of these applications, either because of reoccurring subscription cost, power consumption, or throughput. And so
Right.
that's why I think we've seen this technology really kind of hit a sweet spot, in that perhaps it's not the longest range, perhaps it's not the fastest, but it brings all these capabilities together, and it's the same sort of easy plug and play that you get, with your home Wi-Fi AP.
Nice. Yes, we can see a lot of benefits there, and just in talking about that kind of range, like 800 meters is uh, maybe just something like unachievable with your 2.4 gigahertz regular or 5.8 without some very serious directional antennas, that kind of thing. So
Right. Right. Yeah, and that's a
yeah.
good point as well, right? When we talk about range, really with HALO, we should consider either more area or volume, right?
Mm,
So you can have a Wi-Fi link with directional antennas that can go a very long distance, but
right.
HALO's, a circle, or if you think of a building, it's really more of a sphere, right? So it's
Right.
coverage as area or coverage as a volume, which is really where you get that big benefit. And then, as Takatori-san mentioned, it also has the ability to handle literally thousands of devices per AP, and we have a
Yeah.
demonstration where we've shown over 1,000 devices currently connected.
Wow.
Yeah, it's
That's
neat stuff.
an
Yeah.
incredible number. Yeah. Okay. So shifting gears a little bit, maybe we'll have David, if you could speak to the standardization process. What does that look like for 802.11, and then we'll talk about how it relates to AH as well.
Sure. Yeah. If you have the slides up, I think there's a couple of slides that we have. Basically, the first thing that you want to do when you want to kind of move a standard along inside of IEEE, specifically 802.11 and 802.11, you start up by socializing what you want to achieve. 802.11 does have a WNG, which is for wireless next generation, which is the whole purpose of it is so that you can kind of bring up topics and discuss them and see if there's general interest in moving something forward. If there is enough interest, you go forward and you say, well, let's get approval to start up a study group, for instance. And that's where the S1G study group was formed. And the whole purpose of the study group is to create something commonly known as PAR and 5 criteria. PAR stands for Project Authorization Request. And this is kind of like where you're getting into the scope and basically defining what you want to go off and do. And here, what we document that, and then you kind of what we were kind of discussing was we wanted to get the range up to like a kilometer, and then data rates greater than 100 kilobits per second. Obviously, there we're going to say much slower than typical Wi-Fi, and then you have to kind of show broad market potential. Then along
Nice.
with that you kind of go off and you after the PAR is approved, you get the task group formed, and that you have to create. The first thing is to create a first draft, and to do that, there was a specification framework that was created. After that first one, you go out for a working group letter ballot, and that's kind of refine things, get it to a point where it's a lot closer what's going to be finalized, and move into sponsor ballot, and then you finally get it to a point where you could go and get that amendment published. Then that's basically an amendment to the original standard, and then that has to be rolled in. If you move on to the next slide.
Yeah, we've got that one up here now. The P802.11 AH specification development process.
Yeah, so what we did there was many of the groups will then say, well, how are we going to go off and create our first draft? And what we did there was we created a proposed selection procedure document, and we vote on that, and we said, okay, this is the process that we're going to follow. And what we said was we'll create a channel models document, usage models document, and that'll feed us into the functional requirements that we'll create. And then we'll get technical submissions to achieve these things, and those will be fed into the specification framework. And from that specification framework, we'll basically have an outline of what we want as a specification. And then the editor would take that and he would go off and create the first draft. And that's how you got to the first draft as far as like that first part. And then he moved into the working group letter ballot process. So just like a lot of, not every group, task group, but some where it's kind of a little bit difficult to kind of create that first draft. You want some kind of process. That's what we ended up doing to kind of get the standardization process going.
All right, thanks. Yeah, that's really helpful to give a nice little overview of how that whole process works. I think for the folks who aren't necessarily in that every day, that can be a little tough to understand. So that's really helpful. All right. Next up, maybe let's take a look at what are some of the key features and functionalities of IEEE 802.11 AH. Zach, I know you mentioned about it being sub 1 gigahertz. So how then does this compare frequency wise and maybe bandwidth wise to maybe the traditional Wi-Fi? Oh, I think you're muted there. Sorry.
Right. Yeah. So obviously it's lower frequency, and we have some physics benefits from that. Um, in the sub-gig space, it's a little different regulatory landscape than in 2.4 or 5 gigahertz. And we see that really evolving with HaLow. And I think the work done by AHPC NTT in Japan region has really been accelerating that. But, ultimately, we also see it as another band available when many of these enterprises are now looking at spectrum allocation.
Mm,
So how many devices can I have on 2.4 before I start having problems? How many can I have on 5 gigahertz before I start having problems? And if I want to
right.
bring in hundreds of IoT devices, how do I make sure that I'm not impacting my 2.4 and 5 gigahertz users? So
Sure.
from that standpoint, HaLow also gives you this capacity to offload, to the benefit of those other frequency band, offload those IoT devices. And in the US, we're very fortunate. We have 26 megahertz of spectrum. So HaLow can operate in channel bandwidths, per the specification from 1 megahertz up to 16 megahertz. And there's a corresponding difference in range and throughput. But if you think about 26 non-overlapping 1 megahertz channels available in the US for
Right.
IoT things, it's pretty powerful. It's a pretty powerful tool.
Wow. Yeah, it's using everything to their strengths, right? For sure.
Mhm.
Okay. And you mentioned there about Japan, so maybe we could go to Dr. Takatori here as well and look at um, how the regulations maybe are the same or different in Japan. Um, I think got the right slide here. If I pull this one up, there we go.
Yeah. So in Japan, 11H has been available since 2022, and there are some special regulations. So in 920 megahertz band, there are many other LPWAs, and we need to consider the coexistence with that. And for that duty cycle restriction, we have these special rules in Japan. So it is mandatory to transmit so that each radio station's total transmission time per hour is 360 seconds. It means 6 minutes or less. So 10% or less duty cycle. But setting the observation time to 1 hour, it is then we so by setting the observation time appropriately, we can support various solutions. For example, high-speed transmission only once per hour case. Uh, Maybe we can set observation time to 1 hour. But if we want to support continuous communication, such as video streaming or audio streaming, in that case, we need to set the observation time short. So it's like 1 second or less. In that case, we can support video transmission and so on. So in Japan, I often ask the question that 11H suitable for video transmission because they are worrying about that this duty cycle means if we use first 6 minutes for video transmission, then we can not uh, send video streaming rest of the time. They are sometimes worrying about that. But people don't need to worry about that. So just setting observation time short, then 11H can support video streaming even with this duty cycle restriction in Japan.
Oh, very nice. I think you've got a
Yeah,
graphic here for
that's
it as
yeah,
well. Yeah, that's really helps to illustrate
yeah.
the
The
6 minutes
the
on or not.
the above figure shows the when performing high-speed transmission once an hour. So the first part, this blue part, is the communication part. So in this example, we assume 3
That's
megabps
here.
data
Yeah.
communication for 10 minutes.
Mhm.
So
Mm,
uh, the data communication time is 10 minutes, but the actual transmission time is less than 10 minutes, so like 6 minutes. So we can use this time duration for high data rate communication. And in this application, we don't need to transmit any data rest of the time. So we can do that. But if we want to do the string, so in the bottom part, when performing continuous communication, we need to set the observation time short. But doing this continuous communication, like 300 kbps video data transmission, is possible in Japan. So in Japan, we have duty cycle restriction, but even with this restriction, 11H is useful for various applications.
Mhm.
oh, very nice. Yeah,
Yeah,
so definitely ways to have things, whatever the application may be, and whether you're in Japan or the USA or Europe or anywhere else in the world, this will still be able to work
yeah,
for these applications. Excellent.
Mhm.
Um, just a question here from a member of the audience while we're looking over here. Sebastian has a question for Takatori-san. He says, is the reference standard ARIB standard T108?
T1 very 900 many of these in the so mm, RFID we so uh yeah and now arrived STD T108 includes 11AH. So this
Okay.
standard explains this kind of mechanism. Yeah.
Mhm.
Okay, great. Thank you very much.
Mhm.
All right. I think we had looked at also some use cases. You had mentioned about some multi-link scenarios here.
Yeah.
Um, what are some of these use cases for 11AH?
Yeah. So this figure illustrates the uplink video streaming case, and there are multiple stations. So A, B, C, D, E, F. It means there are 6 stations, and they are transmitting the 11H signal simultaneously. But of course, and the bottom part, it illustrates uh, so the packet transmission. So the blue packet indicates the packet from station A, and the yellow packet indicates the packet from station C. So as you can see, even with duty cycle restriction, we can have the transmission timing periodically. So we can support the data transmission, continuous data transmission with multiple stations. So we can use this kind of multiple station solution uh, in in Japan. Okay.
Great.
So video
Very nice.
transmission and the that kind
Yeah.
of.
Okay. Yeah. Maybe we'll go next to Zach. I wonder. We've talked about sensors. We've talked about cameras.
Mhm.
What are some of the other use cases for 802.11 AH? Is there any maybe unexpected uses that people might not think of off the top of their head?
Yes, we do see. So, what you'd expect is the IoT sensors in the buildings, in the farms. We've seen a number of drone applications and network drone
Oh, nice.
applications that are very, very interesting, and I think show a lot of promise. Um, and even some applications where they're looking at potentially using drones as part of a flying mesh infrastructure that I thought was very interesting.
Wow.
So, for example, if you wanted to inspect a remote power station or power pole or something, you could create a mesh network of drones temporarily that are relaying these signals back. So I thought that was a
Wow.
pretty interesting application. The other place where we see that I think is really exciting is kind of this infusion. I mean, we hear of AI everywhere, and AI is this big
Mm.
story with many different facets to it. But when you look at things, IoT things, they're also getting smarter. So I've seen applications such as learning gas sensors. So you could train the sensor to smell rotten bananas, and they'll throw a
Wow.
sensor in a shipment, and it'll stay with that shipment and then report back. And where HaLow comes in is that combination of coverage and then also enough bandwidth that you can actually download information from the sensor to train your model and then update
Mm.
the sensor with new models. So we're seeing, a lot of sort of
Wow.
evolutionary and then some sort of, really neat new ideas out there.
Yeah, that's really impressive. Kind of the continuous learning kind of thing. And with the temporary mesh networks too, I could see definitely things like in event of disasters, natural disasters, where a lot of maybe the more traditional infrastructure has gone down,
Mhm.
being able to have those temporary ones set up and being able to assess, what does the damaged area look like, and, being able to have communications in those areas. That's potentially a huge use case there.
Yeah, it's a very exciting one. And what's really nice is because it's all Ethernet based, because it's an extension of Wi-Fi, you can
Mm.
move through these mediums easily, right? So you could have a regular router in your home,
Yeah.
plug in HaLow AP, have HaLow
Oh, yeah.
to a kilometer or kilometer and a half, and then go from HaLow back to Wi-Fi to power your laptop, for example.
Wow. Yeah. So very seamless in
Hmm.
terms of working between them.
Right. Yeah.
Okay. Wow.
Yeah.
I'm learning more and more as we go along, and
Yeah.
that's incredible. All right. Well, maybe let's look at. You mentioned having APs, access points for this already. What sort of products exist on the market today for Wi-Fi Halo? And are there more coming? Can people buy these already?
Hmm. Yeah, so there are products on the market. There are products that people can buy. Halo is still early, so there are a lot of designs that are being done, and there's some products that are out there that use Halo.
Mm,
They don't necessarily say they're using Halo, so you just see the benefits of the performance.
wow.
But yeah, absolutely, products on the market. There's some behind me, like this is a little access point, in fact, right?
Wow,
So
that's tiny. Yeah.
it's a tiny one. More traditional ones are like this, right? So much, kind of more what you would imagine.
Yeah.
But, we see both the indoor and the outdoor use cases. So some are better geared to larger devices, and some are, they want that small portability,
Mm,
focus on low power, low cost infrastructure.
sure. All
And I
right.
think, one other thing that's kind of, I think wonderful about HaLow, and really a testament, is we have Dave, Dave on here from Morris Micro. I'm from Neurocom. Is interoperability. So I
Mm,
think interoperability has been foundational to Wi-Fi Nobody asks you, hey, what kind of Wi-Fi radio do you have in your MacBook or in your Dell
Right.
notebook, right? That's been taken care of a long time ago, in that it interoperates. And
Mhm.
interoperability has not really been present in the IoT space, and HaLow brings that. So the HaLow devices work together. We test with other HaLow vendors. There's a HaLow certification in place. So that's the other kind of benefit, is you aren't locked into proprietary. It's multi-vendor, and then that also allows the vendors to kind of pick their specialization. So the community really
Sure.
wins.
Wow. Yeah, it's a key factor there, the interoperability for
Mhm.
sure. Um, all right, so we've got another question from the audience come up here. What channel models were used in the IEEE standardization development? Did you use the standard Okumura Hata path loss models for large scale, and how about small scale?
I'd
Um,
have to defer to Dave on that if he knows that.
yeah, Dave, is that one you can answer? I'll say again here. What channel models were used in the IEEE standardization development? Did you use the standard Okumura Hata path loss models for large scale, and how about small scale?
That what we did was there was we did do a channel model document, and there was I believe this is going back a little ways. I'm trying to remember that there was both an indoor and outdoor,
Hmm.
and uh, so we could probably follow up offline, but the and get back to what those exact channel models were used.
All right, thank you very much. Yeah, always some good questions coming in, and some expected, some unexpected ones from the audience. So those are great. Um, let's look at maybe some next steps. We've looked at kind of like where we're at now. Um, what are some areas that maybe Wi-Fi Halo will be going next? And I think we've got another one of Dr. Takatori's slides here.
Thank you.
There we go.
So the left figure, the current 11H market, this part explains current market. So agriculture and livestock, local safety, and the uh, school, because we want to use many video cameras in school. And
Oh
the
yeah.
disaster prevention is also one of the good use case. But currently, 11H market is limited to this area. And this is just because of that 11H is in the beginning stage. So more and more varieties of devices and applications are expected in the next step. So maybe the first two boxes, so factories, logistics, regional revitalizations. So these parts are extension of the current 11H market, and we can enhance various solutions in these sections. But we are thinking that in the next step, there may be more new markets. So like office solution, and also we can use 11H at home. So for example, for smart home applications, there is a standard called MATA, and it can connect to various IoT devices. So if we can use 11H with MATA, then it can be a powerful tool. We think that. Yeah.
Yeah, that's a great point about smart home devices as well, because we have more and more of those in our homes today, and they tend to be very, very far away. Maybe you'd have cameras
Yeah.
outside. Maybe you've got a doorbell camera.
Yeah.
You might have, sensors in the backyard as well. So these things tend to be very far from our router, but with the
Yeah.
range capabilities of 802.11ah, suddenly that becomes much easier for those devices to work and connect, right?
Yeah.
Mhm.
Yeah, I believe so. So even in home application, there are many use cases, indoor, outdoor use case. In that case,
Yeah.
current Wi-Fi cannot support such connection, but
Mm,
11AH can use sub 1 gigahertz. So it means that we can cover large area. So even at home, uh, we can extend many use cases. So we are expecting 11H solutions for smart home solutions. Yeah.
oh, very nice.
Mhm.
Um, I know this was another one you had brought up here, this
Yeah.
NTT East.
So yeah. Uh, so there is one article. So this link is only in Japanese, sorry, but it is saying that why NTT East is enthusiastic about smart homes becoming pretty popular in 2024. And the new Wi-Fi standard makes it easier to connect. And in the article, NTT East guy is explaining that we believe that by promoting Wi-Fi Halo, the instability of communication will be resolved. And the Japanese operator is also thinking that Wi-Fi Halo is a good tool to improve the smart home solutions. Yeah.
All right, very nice. So I guess with traditional Wi-Fi, we've got multiple bands as well. Like there's the 2.4 gigahertz, 5.8 gigahertz. Um, does Wi-Fi Halo currently have multiple bands, or is there any thought to having that, a band extension in the future? Um,
I can explain the situation in Japan but maybe other people will explain other countries' situation. But
sure.
I want to explain uh, frequency band in Japan. So as I explained that uh, currently 920 megahertz band is available for 11H. But now we are working for new frequency band allocation. So, and in Japan, digital MCA system operating in both 845 to 860 megahertz band and 930 to 940 megahertz band.
Hmm.
But they will move to different frequency band. So we are thinking that this frequency band is suitable for Wi-Fi Halo. And actually, uh, this April 2024, Japanese Ministry of Internal Affairs and Communications, has launched an official working group to discuss the frequency allocation of 845 to 860 megahertz. So new frequency bands. And the candidate new wire system is R11AH and the Metropolitan Beacon System, MBS. And we have started discussion on that. So we are expecting this new frequency band for 11AH Wi-Fi Halo. And so this is
Right.
very uh, good news, I think. Yeah.
Yeah. Yeah, definitely. Adding more frequencies will expand the possibilities for this technology.
Yeah.
There are there similar efforts happening in other parts of the world? Zach, do you know?
Yes, yes, there is. So we have regulators have been looking at sub-gig space for some time. I think with the advent of the LP WANs becoming more popular. So we do see this, and in fact, in Europe, there's a section of the 900 megahertz that's been made available in some countries, but it's not harmonized at this point.
Okay.
And so it takes time, of course, to change like
Sure.
regulations, and there has to be
Hmm.
strong value proposition. But what we see is, our customers are realizing that spectrum is scarce, and efficient use of spectrum is important. And within 11AH, it has like the listen before talk capability. So it's a polite technology that works well with other technologies. And then it's also just very efficient in how how much data can send in a short period of time and get off the air. So we see those two things kind of working hand in hand with additional spectrum to enable more use cases.
Excellent. Well, as a polite technology, that's a very nice analogy for it, for sure. Working well with others. So as we're getting close towards the end, if there are any more questions from our audience, please feel free to put those in the comments, and we will get to those as well. Um, just sort of maybe a wrap up here of some of the top features that we've gone through. The sub 1 gigahertz spectrum operation, the power saving, getting all the latest Wi-Fi security, because as Zach mentioned, this is still Wi-Fi based. No need for proprietary hubs, that type of thing, and months or even years of battery life. That's incredible. Are there any additional thoughts that all of you might have? Maybe we'll start with David on this. Any final thoughts that you have on Wi-Fi HaLow? Any takeaways?
Yeah, yeah. The thing that we're seeing is that there's a large potential here, and one of the things that whereas within IEEE and Wi-Fi, that since we're all based off of 802.11, we could also then take advantage of any of the current work that additionally goes on. So the base 802.11 AH was from a little while ago. Since then, there's been a lot of work done, and like the next step as to the success of HaLow starts, really picking up. We could take a look at even extending, going beyond where the feature functionality that HaLow currently has, and bring either Wi-Fi technologies such as mesh and hotspot, and so there's just a large number of feature functionality that's in the Wi-Fi Alliance, and then also within IEEE to 11, any of the additional functionality and features that's technically that they come along with that may be applied to a different technology, and then we can kind of say, hey, you know what, this is sort of like a good idea. Maybe we want to apply this to sub 1 gigahertz and HaLow. So there's just a tremendous amount of future for HaLow.
Yeah, I'm excited for the possibilities for this technology. Even just the things we've talked about over the last hour here. There's seemingly so much that it can do. And as well, I guess we'll go next to Yasushi. Any final takeaways that you want the viewers to go away from with this?
Yeah, I think 11H is still in the beginning stage, so we want to have more and more varieties of 11H devices, and that variety of devices can push the new market, I believe. And I and the in this live stream, I explained the new frequency band allocation in Japan, and I want to add some for that. And now we are working for this regulation, and we are trying to the regulation more flexible compared to 920 megahertz band. So we want to remove the duty cycle restriction in this frequency band.
Mm.
And also we want to increase the transmission power. Currently in Japan, 20 milliwatt is the maximum transmission power is 20 milliwatt.
Wow.
But we want to increase it to 200 milliwatt. Then we can apply 11AH for various solutions. So we want to enhance 11AH and create a good new market with 11AH. Yeah, thank you.
Wow. Yeah, 20 milliwatts, and it still has such incredible range. Just thinking about increasing that, would be able to do even better. That's a
Yeah.
great point. And we'll go to Zach as well. Takeaways for our audience here.
Well, I think it's a technology that certainly, if you're looking for connectivity technology in 2024 and beyond, it's worth considering. It's really exciting for me because we spend a lot of our time in the field testing this and seeing the real world performance. And we're continuing to do that with the proponents and the adopters of the technology. It is in early stages, but it's very promising.
Yeah, again, this technology has a big future ahead of it and a lot of accomplishments already. All right, so as we're wrapping things up here, if folks want to get involved, you can get more information about all of this on IEEE802.org, or go to standards.ieee.org. You can check us out there on LinkedIn as well, either Standards Association or IEEE 802. If anyone wants to reach out to any of you if they have questions or just follow up thoughts or anything like that, can they reach out to you on LinkedIn as well? Or
Absolutely.
all right, sounds great.
Great.
We will have a short survey as well. There's a 3-question survey. If you like this and want to see more like this, go to this survey here. You can take a photo of that and let us know if you. There's the link here as well. If you want to have different topics that you want to see for these next ones, we did one in November on Li-Fi, light-based, infrared connectivity. This one here on Wi-Fi HaLow. What's next? Well, maybe that could be up to all of you. So I'd like to thank again our 3 wonderful speakers, Zach, Yasushi, and David. Thank you to all of our audience as well for joining us, and I hope that all of you will join us next time as well. Thanks, everyone.
Thank you.
Thank you.